Hi folks, so in this video what we're going to be doing is we're going to be covering some short answer questions, just two questions in regards to the area of tangents. Okay, a little bit of recap in regards to a mock or any exam that you're preparing for that will teach the principle of how to use a tangent or construct a tangent. So you can see here it says the radio has a manual tuning dial. Okay, this is from last year's, I think, Junior Cert mock paper. It says an outline drawing of the tuning dial is shown across. Okay, so we can see here we're given a circle C and we've got a point P up here that is connected to the outside of the circle. These are our tangents. Then it says complete the drawing of the tuning dial below by constructing tangents from point P to the circle C. Now, often for the principle of a tangent, P, which is the point that we're drawing the tangents from, a tangent is essentially a line that is touching the outside of a circle at one point. Okay, that's going to be our end result, like that and like that. However, even though that is the end result, and you might get a mark for just putting that in, you won't get the full marks because you have to prove the construction and locate the points of contact. So how you do that is, first of all, you connect the point you're drawing from to the center of the circle. Now, luckily enough for us in this case, in this question, the point P is already connected to the circle. So step one is already done for us. You connect P to the center of the circle. Then the distance from P to the center of the circle, I have to bisect that. So from the middle of the circle, pick a distance that is greater than halfway, which is about there. So I'm going to pick a distance about here. Same distance on the compass, so we can arc out the opposite side. To extend my arcs a little bit. There we go. And now that I've bisected the line, locate the middle. I can see that the middle is right in here. Now that I've got the center of the line, I'm going to swing a semicircle. Does not matter what side I do it on. So from the radius or from the new center up to P is the radius length for my arc. I want to swing a semicircle like that. Now what's helpful to me is that semicircle where it cuts through the circumference of the circle, right there, is locating to me my point for my tangent line. So that tangent connects from P to there. That point there is known as our point of contact, sometimes noted with the letters POC. If I wanted to find that on the opposite side, I could simply do a horizontal line straight across, okay, if you have a T-square set up, or alternatively, I could just do a semicircle on the opposite side, like that as well. And that will get me the exact same result. Once again, locating my point of contact for the opposite side. And now I'll connect that up as well. Okay, there you have it. That is the question completed. Now, just a little bit of background on that. If I was to connect the point of contact to the center, like that, the relationship between the tangent and this line here, which is actually called a normal, is that they are 90 degrees to one another. So technically, if you have the normal, you can actually find the tangent, because where the normal cuts through the circumference will give you the point of contact for the tangent as well. Okay, likewise on this side, if I was to connect the center to there, that would be at 90 degrees to my tangent line. So that's that question done. I'm going to move on to the next question now. We're going to do another tangent problem. So look back in my booklet here. And here's the next question that we're going to be doing. So this question here, it says, question number 14, the incomplete outline of a sports mouth guard is shown. A 3D graphic of the mouth guard is also shown. So we can see here, we've got the 3D graphic and we have the 2D line diagram here. It says, complete the outline of the mouth guard by constructing tangents from P and Q to the circle C. Okay, so you can see here we've got a portion of a circle, it's obviously incomplete, and we have to get a tangent to complete it. Now our tangent, if we're going to make the mouth guard, I assume is going to look something like, I'll just put it in here as best I can, something like that, and then from Q, the exact same on the opposite side. That's what we're going to have to do. Okay, but once again, same principle, we have to prove it. So in this one here, you can see our circle, center C is right here, and our point P is the point I want to get the tangent from, going like that. Now, unlike the last question, P is not connected to the center, so this time I have to connect it. So step one, connect P to the center of the circle. What do I do with that line? I need to bisect it. So this is step two. So pick a distance greater than halfway. Bisect this line, pick an arc above and below the line. And that crosses there and here. Having bisected that line now, got the middle there, I'm now going to swing a semicircle with the radius length from the center of the line out to P. I'm going to swing a semicircle like that. Where that semicircle, I don't have to do it the whole way to the center, but I will. Where that semicircle cuts through my original circle C, right there, that there is my point of contact for my tangent. I'm going to connect this guy down to here. So even though I knew where the right result was, it's still important that I can prove it. Okay, same principle will apply on the opposite side. I would connect Q to the center. Now I don't have to do this because it's symmetrical. If I was just to bring this line straight across to here, that would locate my point of contact. But just to go over the principle again, you connect Q to the center, bisect that line, so pick a distance greater than halfway. And then where those lines cross each other, here and here, I've now found the center point. And once again, radius length, this time I'll set the radius length from the center of the line to the center of the circle. Should still give me the exact same answer. Semicircle, around like that. There we go. Once again, where the semicircle cuts through right there, that is known as our POC, point of contact. So I can heavy in that tangent line now. Okay, now that I've got the tangent line, you can see the outline for the mouth guard. So I'm just going to add in a little bit of detail. You don't probably have to do this. I'm just going to heavy in that portion there as best I can. And there we go. There is the mouth guard completed. Okay. If I was to find normal, okay, if you remember previously I said a normal is going to be perpendicular from your tangent, so perpendicular from the point of contact to the center. If I was to do a line like this, that line there is a line called the normal, and once again you can see it is at 90 degrees to our tangent. Okay, so that there, guys, is another little question that loves to crop up in a junior cert graphics paper, okay, where they test you and your understanding of tangency. It will come up in some aspect, and sometimes it can come up in a short question. Okay, so once again, guys, I hope you found that helpful.